In this online lecture, we're going to learn how to do some basic nomenclature. When we're looking at alkanes, we have general formulas, and just a reminder, for acyclic alkanes, that means they don't have a ring, there are 2 hydrogens plus 2 for every carbon. If we have a ring in there, 2 of the hydrogens are removed, so the ratio is 1 to 2 for the compound. And this is regardless of whether or not these things are branched or simple. So keep that in mind. The characteristics of the alkanes, because they're all made of carbon and hydrogen, that's all that's in them, they're nonpolar. And so they're not water soluble and they are hydrophobic. That's why we say water and oil, which are basically alkanes, don't mix, because there's nothing there that allows water to hydrogen bond to it. Alkanes have low melting points and boiling points unless they have a really large mass. And all portions, any kind of portion of an organic molecule that is made of carbon and hydrogen, it's all hydrophobic and resists moving into water. So even if there's a functional group on there that can hydrogen bond to water, the rest of the molecule that's carbon and hydrogen are hydrophobic. Okay, we've seen that carbon can make chains, and they can make really, really, really long chains. I've just given you 10 of them here. The number of carbons in that chain is very important because that tells us what the beginning of the name is going to be. These are the prefixes that we use in organic chemistry, and they say how many carbons are in that chain that we're looking at. So here are some examples. This is methane, because meth stands for 1. F stands for 2, and so we call this ethane. And prop stands for 3, so this is propane. Notice they all have A-N-E on the end, and that's indicative that it is an alkane. And so the ending on a name tells you what functional group it has, and the alkanes have no functional group. You can have substituents, and this is anything that's attached to the carbon chain. They can be carbon chains, which we call branches, or they can be heteroatoms. The carbon chains we call alkyl groups, and the heteroatom substituents have their each specific name. And those heteroatom substituents are our functional groups. To place our substituents so that we're very precise in conveying the structure of the compound, we always find the longest chain, whether it's bent, straight, flipped, or flopped. It's whatever connection of them all in a row is the longest. Then we number so that we get the lowest number for the location of the substituents. And the substituents are the same prefixes that we use for the chain, but instead of having "ane" on the end, they have an "ill" on the end. And we put a number to say where it is. Okay, now here's an example that we're going to go through to demonstrate this. First thing that we do is we find the longest chain. And if you look, you can see there are 5 carbons in a row there. That's our longest chain. Although we really could have gone that being our longest chain. It gives you the same name either way you go. Okay, next we have our longest chain of 5. That gives me my pent in there. I look and I see no functional groups, so that gives you the ane. This is a substituent, something that is attached to the chain. That has only 1 carbon in it. 1 carbon prefix is meth. So I say meth, ill, remembering this means attached. And then I number it. And so I always want to get the lowest number, so I count from either end of the chain. 1, 2, 3, 4, or 1, 2. And I say 2-methylpentane is the name of this compound. So on all of our substituents, you will see an "ill" ending. If it's carbon-based, we just use a carbon prefix, the prefixes. So we say methyl, and it can be written this way, or the bond to the carbon chain going up or going down. Very flexible. 2 carbons means eth, so this is ethyl. Notice 3 hydrogens on the end carbon, 2 on the one that's going to be attached to the chain. And it can be written upside down, backwards, right side up. It just has to be in this order that they're attached. They can be written backwards, but 3 hydrogens on the carbon on the end. Propyl, that's 3 carbons. Butyl, 4 carbons, and it's missing the "or" over here. There's other possibilities, and I didn't put it all in. Any length carbon chain can be a substituent. So what you do is you count the carbons, you get the prefix, and then you add "ill" to the end. So let's go through the system. Count the carbons in the longest chain. Draw a line through it. If you draw a line through it, you won't count carbons twice. If you count the number of carbons, that's going to give you the prefix. And you would then see no functional groups, so you put "ane" on the end. After that, you name the substituents and you list them in alphabetical order before the alkane name. You go back and you look to see where are the substituents placed on the chain. And you number from either end of the chain, and then you pick the lowest numbering system. Only use one numbering system for all of the molecule. You can't switch numbering systems in the middle of naming. If you have more than one of a particular substituent, then you would use like di for dimethyl, triethyl, tetrapropyl, diethyl, trimethyl, tetrabutyl. You know, all these, it's indicating how many of those are on the chain. Okay, now you've got an opportunity to try it. Take the rules and see if you can name these compounds systematically. All right, the first thing is to find the longest chain. And you can see there's 5 here, there's 5 here, 4 here, 4 here, and 4 here. Which one gives you the longest? Well, it doesn't matter. Any of the 5 carbon chains will work fine. They both give the same name, you would find out. So there's my longest chain. What are the substituents? Right here and here. Now that I've analyzed my compound, I'm going to name it. So the longest chain gives me pentane. There are 2 methyl groups, so I'm going to have to say dimethyl. And then I locate them. From this end, it would be 3 and 4. From this end, it's 2 and 3. I pick the lower numbering system, so I get 2,3 dimethylpentane. On this compound, there's a lot of possibility for chains, but you'll find the longest chain is right there. We have an ethyl group here and a methyl group there. Why do I know that's ethyl? Because there's 2 carbons in it. How do I know that's methyl? 1 there. So now, remember, you can't count the carbon that's here except for in the chain. So now the longest chain is 8, and so we say octane, and there is a methyl and an ethyl. Remember, we put them in alphabetical order. Then we locate the numbers 1, 2, 3, 4, 1, 2, 3, 4, 5. 4 is lower, so we put 4 in front of each substituent. Go ahead and try these now. Okay, the longest chain here is 5, and we have 2 methyls. We're going to say 3,3-dimethylpentane. A common mistake is to leave off the extra 3. See, there are 2 methyl groups, so we have to have a number for each one. If there were 3, we would have to have 3 numbers. You see, every one that's on there has to have its own number. Okay, if I go to this one, there are 6 in the longest chain. So we get hexane. There's an ethyl group and a methyl group. So it's ethyl-methyl. If I number from this end, it's 1, 2. If I number from this end, it's 1, 2, 3. And so we choose the lower number, 2, which gives us 4 for the ethyl and 2 for the methyl. A common mistake is to number from this end for this one and this end for that one. You can't do that. You have to have one numbering system. Go ahead and draw structure for each of these molecules, making sure that you can do this. A simple way that many students find useful is to draw 6 carbons, let's say for this, and then on the number 2 attach 1 carbon, and then on the number 3 attach 3 carbons, number 3 attach 2 carbons, and have those carbons written out. Once you get it on there, you would see that it's kind of easier to count. Then you can convert it to a skeletal structure. Okay, this is 3-ethyl 2-methylhexane. 1, 2, 3, 4, 5, 6 carbons. On the number 3 carbon, you have 1, 2 carbons. On the number 2 carbon, you have 1 carbon. Right here, 7-ethyl dimethylpropyldecane, you will have 10 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On the number 7 carbon, it doesn't matter which end you start from. You can start from this end or this end. So if you look, I started from this end for the numbering. 1, 2, 3, 4, 5, 6, 7, and I put an ethyl group. On 2 and 5, on 2, 3, 4, 5, you can see there's methyls. And then on number 4, you can see we have a propyl, 1, 2, 3 carbons. 3-ethyl 4-methylhexane. We have to have 6 carbons in a row, 1, 2, 3, 4, 5, 6. On the number 3 carbon, 1, 2, 3, and the number 4 carbon, 1, 2, 3, 4 methyl. Notice that ethyl comes before methyl, and we could have used 4-ethyl 3-methyl in this name, but when it comes, see, from this end it's 1, 2, 3, from this end it's 1, 2, 3. When it's equal, you give the one that has the lowest alphabetical order the lower number.